In this video, I'm going to tell you why we are all here. Not necessarily why we're here in this universe, although we're kind of going to answer that too. But mostly, why are we here in this course? Why are we taking a course on electromagnetism? So if you read the course description, you might see stuff like electrostatics, magnetism, circuits. And when you read these terms, you probably have some kind of idea what they're about, right? You think electrostatics, okay, that's the thing that makes my hair stick up if I rub a balloon on the carpet and hold it over my head. Or that's the reason that if you've got a kid going down a slide and then they're charged and you touch them and you get a shock. Or magnets, those are the things that stick to my fridge. Maybe you think of compass needles. In circuits you think of, light bulbs and wires. Is that what this course is about? Sure, but not really. Right? The course is really about something that's way more fundamental. It's called electromagnetism because these electrostatic forces and these magnetic forces, they're actually kind of the same, or they're very closely related in ways we're gonna come to. But so what is it about this topic that it deserves its own course? So let's remind ourselves what we learned in your previous physics course in Physics 161, or in any other mechanics course you took. Something very fundamental that you learned about were forces. What are forces? Forces are interactions. Right? You met all sorts of forces in your course. What types of interactions did you meet? Well, you met gravity, right? Weight. Maybe Newtonian gravity, the force between, the theory that describes the gravitational force between two planets, or the sun and a planet, or an asteroid, or really any two objects, right? Not just weight on Earth. But you also met stuff like tension forces, right? Springs or strings or rubber bands. You had stuff like friction. You had stuff like thrust, right? A rocket going up. You had normal forces, things not falling through other things. You had air drag. And, somewhere down the list you also had electrostatics forces that make a hair stick up. Or magnetic forces that have to do with fridges, compass needles. But if you actually were to zoom in, if you like, to what's going on at a microscopic level during many of those interactions, what you'd figure out is that most of them aren't really fundamental. And if you keep investigating, you're going to learn that supposedly, or our best theory of physics tell us, there are 4 fundamental forces. And I'll explain what I mean by fundamental in a second. Now, one of those is indeed gravity. And it works pretty much the way you've met. Yes, we can have a more sophisticated theory of gravity called general relativity, but that's, a subject for another day. All in all, gravity works the way you learned, the way you used it in Physics 161. The second type of interaction are electromagnetic interactions. And that's what this course is about. This force, gravity, is what holds the universe together. It's the reason why there are planets, why there are galaxies, why there is anything at all and not just a sort of dilute gas-like substance that is about the same all over the universe. Right, this is the reason matter forms clumps like planets and stars and galaxies. This force is the reason anything else really works the way it does. Like anything else that you've met works the way it does. All those forces up here, and not gravity, but all those guys, they're really just versions of this. Let's take normal forces, right? What's a normal force? Normal force is the thing that stops this pencil from falling through the page. But if you zoom in to the surface where the pencil touches the paper, what you see is the molecules inside the pencil make up the wood of the pencil, repelling the molecules that make up the paper. It's a bit of a simplistic picture, but that's essentially the essence of it. The electrons and nucleons, protons, neutrons, all that stuff is complicated, but it's an electromagnetic interaction that at a microscopic level stops this pencil from falling through the paper. Right? The atoms and molecules at the bottom of this pencil, they push against the atoms and molecules on the paper, and the reason they just don't fall through them, atoms are mostly empty space, molecules are mostly empty space, the reason they don't fall through each other is because of electromagnetic interactions between the particles that make up this and the particles that make up this. Friction, same thing when you drag something across the surface. Well, what's happening is a bunch of very complicated interactions on the microscopic scales that are all ultimately electromagnetic in nature. And so on, like tension, right? If you stretch a string, you're changing the way the molecules are arranged inside that string. The way they are arranged, the reason they are arranged at all, the reason a rubber band is a thing that's not just falling apart into its individual atoms and molecules, is because of electromagnetic interactions. Right? So gravity holds the universe together on a large scale. Electromagnetic forces hold things like this pencil together. It holds stuff together. And stops stuff from falling through other stuff. Right? Most of your everyday experience, the types of forces you deal with on a day-to-day basis, those are things that are really, when it comes down to it, electromagnetic interaction at a microscopic level. It's the thing that determines atomic structure. Electrons in their shells. Therefore, chemistry. Right? Chemistry as a whole subject is the result of studying this interaction on the level of atoms and molecules. Right? Atoms and molecules are things that exist in the first place because of this interaction. Gravity holds the universe together. Electromagnetism holds almost everything else together. And that's why it's so important. Now we've got two forces here. What are the other two? The other two you probably won't meet, at least not for a while, unless you keep going in physics. One of them is called the strong force, or the strong nuclear force. And that's the force that holds the nuclei of atoms together. The protons and the neutrons in the center of your atom, they're held together not by electromagnetic forces. In fact, electromagnetic forces would want to blow up your nucleus. But the strong force is what holds them together. And then the weak nuclear force, the weak force, well, that essentially is responsible for some fundamental processes involving fundamental particles, like certain particles decaying, changing into other particles, for example. The most famous one is so-called beta decay. So those are, I mean, without those, right, the universe wouldn't exist, or there wouldn't be stuff the way we know it, right? So it's not that they're not important, but in a sense, we don't have to worry about it most of the time. Like only in really the high energy fundamental physics experiments do we have any chance of accessing anything about those. So what that means is if you're not studying gravity, you're pretty much studying this. Now, I could add that another reason to study electromagnetism, in a sense, is that if you were really going further and further in physics, right? If you want to be a physics major, then the structure of this, at a very fundamental level, is sort of going to help you to understand those better. It's kind of a simpler version of those. But that's really going into the standard model of particle physics, which is way beyond what we're doing right now. So the reason this course exists, the reason Physics 162 is a thing, is not because of circuits and making your hair stick up, fun as that may be. We're going to do all of that. But the fundamental reason this course exists is because it is the electromagnetism is the dominant interaction in most of your everyday experiences. It's just that you're not aware of it.